Hey, good morning. Let's look at our 3, 4, 3, 5 equations of parallel and perpendicular lines. Our first theorem says that if two congruent angles form a linear pair, then the angles must both equal what? Let's think about what a linear pair is. A linear pair is a pair of angles that add up to a straight line or add to 180. Those are supplementary. So if I had two angles that are exactly the same, add to 180, or each one is half of 180, then what would each angle be? Well, each one would have to be 90, right? And let's check. Let's see if we are correct. So angle 1 and angle 2, they're congruent, right? By our right angles congruence theorem. So they're congruent and they form a linear pair. So let's check. Does 90 plus 90 get me 180? And it does. So they are a linear pair, which means that we are correct. By our right angles congruence theorem and the definition of linear pairs, those two must be 90-degree angles. And our two more important theorems say that if a transversal, here's my transversal, J, that transversal is perpendicular to one of my two parallel lines. So it's perpendicular, forms a right angle. Then it is what to the other line? What relationship does it have? Let's check out our corresponding angles. They're in the same location, and we know that corresponding angles must be congruent. So if that's 90, then this must be 90. And then what do we call two lines that form a right angle? Well, we would say those are perpendicular. So if it's perpendicular to one parallel line, it must be perpendicular to the other one. And the converse of that is that if two lines are perpendicular to the same line, so now we've got these two parallel lines given to us, and they tell us that they are forming those right angles. So if these two lines are forming right angles with the same line, then they must be parallel. Remember, that was our converse, where if those corresponding angles are congruent, then the lines are parallel. So we can use that converse here as well. And that's not really anything new. It's a special case of what we've been looking at last week. So using those last two theorems, let's look at some examples. I want to determine which two lines are parallel. Well, here's a right angle, and here's a right angle. So D is perpendicular to two different lines. So if it's forming a right angle with two lines, then what do we know about those lines from our theorems up above there? Well, if it's perpendicular to the same line, two lines are perpendicular to the same line, then these lines must be parallel. So A and B must be parallel. I should really write that as line A and line B are parallel. Okay, in our second example, the diagram below shows the outline of a garage. We're given that these lines are parallel. I'm given a right angle. So these are my parallel lines. I'm given a right angle here. And they want me to tell them, is RS going to be perpendicular to TS? So does that form a right angle? Why or why not? And think about what is that angle? How does that angle relate to my right angle? Well, that angle and the right angle would be consecutive interior. And what do I know that consecutive interior angles add to? They've got to add to 180, so I've already got 90, plus what is going to get me 180. And I can subtract 90 to get my final answer here, so this angle must be 90. It's my 90-degree angle. And that's saying, is RS perpendicular to ST? Does it form a right angle with ST? So is that forming a right angle there? And yes, it is. And we could also use that theorem that if a transversal is perpendicular to one of two parallel lines, like it is here, it was perpendicular to QR, then it must be perpendicular to the other one, ST. And why are we talking about these perpendicular lines? What's the point? Why do we care about perpendicular lines? Well, think about it. What path would you take if you were jumping over that creek? Would you take the path A to B? Would you take A to D? Would you take A to C? Would you take A to E, and why? So think about that. That's why we're talking about these perpendicular lines. And of course, you would jump A to C. It's the shortest distance, and it's perpendicular. So that's why we care about these perpendicular lines. They are the shortest distance between 2 points. And now let's get into some algebra. I want to find the slopes of those parallel and perpendicular lines. Our slope formula we know is rise over run, or y2 minus y1 over x2 minus x1. And if you're going to call this, you could pick that's x2, y2. That would be fine. And this would be x1, y1. Then just make sure that you pick x2, y2, and x1, y1. So we would plug in y2 minus y1, negative 3 minus 3 over x2 minus x1, 0 minus 0, negative 6 over 0. Or down here, y2 minus y1, 0 minus 0 over x2 minus x1, negative 3 minus 3. So this would be 0 over negative 6. And once we find these, we're going to look for very specific types of slopes. Parallel slopes and perpendicular slopes. That's really what we're going to focus on. So parallel slopes are the same number, the same fraction, whereas perpendicular slopes are opposite reciprocals. And I'm going to skip 1 and 2. I'm going to go to 3 in just a minute. But let's talk about what opposite reciprocals means. Opposite reciprocals, an example of that would be, I'll do it in red. An example would be 2/3 and negative 3 over 2. So you can see I flipped my fraction, and I had a positive fraction, and I had a negative fraction. So flip your fraction and change the sign. They should have opposite signs if they're perpendicular. Now let's try number 3. I've got x1, y1, x2, y2, and again, as long as you're consistent, it really doesn't matter. But I'm going to say that's x1, y1, and x2, y2, just to keep it consistent. We'll use our slope formula, y2 minus y1 over x2 minus x1. So let's see, y2 is negative 2. minus y1 of positive 6. And then x2 is negative 5 minus x1 is negative 1. So my slope of AB would be negative 8 over negative 4, or 2 over 1. And then CD, or I'm sorry, that was CD. Let me move that over. So that was CD. AB, I'll do y2 minus y1, 2 minus negative 12, over x2, negative 2 minus x1, negative 9. So that's going to be 14 over 7, which is a positive 2 over 1 if I were to simplify. And notice that these have the same exact number for their slope. They're both 2 over 1. So if they're the same number, then they must be parallel lines. All right, and our last problem type here, given the equations, we're going to find if these are parallel, perpendicular, or neither. So remember, parallel is the same number, perpendicular is opposite reciprocal, and neither would just be neither one of those two. First one we're going to look at, my slope is in front of the x in our y equals mx plus b format. So my slope is 4 over 1, and then my slope over here is a negative 3 over 1. And it doesn't look like there's any relationship between these two fractions. They're not the same number, and they're not flipped. So this would be a neither. Okay, let's try B. Again, look at that number in front of the x, 2.5 and 2.5. And if that's the same number, then those must be parallel. And for these last two, we have to get the y by itself. We need to get it in that y equals mx plus b format. So I'm going to subtract 9 to both sides to get y equals x minus 9, and I'll add 11 to both sides over here to get y equals negative 1x plus 11. So let's look at our slopes. I've got 1x and I have negative 1x. Or I have 1 over 1x and I have negative 1 over 1. And they're not the same numbers, so they're not parallel. But if I took this fraction and I flipped it upside down and I threw a negative in there, would I get that fraction? And I would get that, which means that these are perpendicular. It's that opposite reciprocal. I've got neither, and I've got perpendicular. And D, I'll simplify. So I'll divide by 4, y equals 1/2 x, or 2 over 4x minus 4. And I'll divide, oh no, I need to subtract this 16x over here. So 8y equals negative 16x plus 24, and then divide by 8. And I'll get y equals negative 2 over 1x plus 3. And again, let's focus on those slopes. It looks like I flipped my fraction. And I threw a negative in there, which means that those would be perpendicular. Let me know what questions you guys have. Send me an email or join my office hours, and I will see you guys tomorrow.